viewers, welcome to CEC lectures. Myself Dr. Preeti Jagmani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So today we are going to study our virtual functions, and this is a part of the series Introduction to Programming using C++. Before this we have covered couple of lectures about virtual functions, and in those lectures we have seen almost all the basics and fundamentals about virtual functions. Let's have a quick recap, and then we will formally begin with our agenda for today. So when we talk about virtual functions are actually member functions which are declared within a base class, and in the derived classes of those base classes these functions are redefined, or we can say these functions are in a way given a new definition, and these are overridden. Now why do we need this kind of arrangement? Because this is one thing through which we can implement our one interface multiple methods, which is the kind of bottom line, or which is the agenda of polymorphism. Now polymorphism is one of the basic features of object oriented paradigms, and in order to implement runtime polymorphism we need to have one interface multiple methods which will be implemented with the help of virtual functions. Now in the case of virtual functions, when while referring to a derived class object using a pointer or maybe a reference to the base class, a virtual function can be called for that object and execute the derived class version of the function. So in this way we have one member function declared within the base class, that member function redefined by derived classes, and the derived class version, or we can say the required version, will be executed depending upon the pointer on the or the reference, we can say. So this was the kind of fundamentals which we have already covered in our previous lectures. Now today what we are going to study is the inheritance of virtual functions, or we can say more specifically we can say inheritance of virtual attribute. Now let's see what this inheritance of virtual attribute is meant by. So let's say we have one base class in which we are defining one print function, and that print function is a virtual function, and that is saying that's just printing print base class, and within this base class we have one function show, which is a normal function. Normal function here means a non-virtual function, and that function is printing only show base class. So the code regarding this base class you can see on the screen. We have hash include iostream, hash include namespace standard, these two standard we can say statements, and within the base class in the public section of base class I have two functions. One is a print function which is defined as a virtual function, which is declared as a virtual function, and another function which is the show function and declared as a normal function. Now when we say that we are talking about the inheritance of this virtual attribute, what do we mean? Inheritance of virtual attribute actually means that whenever we are having one function which is virtual, one function which is non-virtual, and these two functions are actually we can say redefined in the derived class, how they will behave inside the main program. Let's try to see. So apart from that base we have one derived class which is inheriting this base class in public mode, and within its public section, within the public section of derived class we have those two functions with the same name. One is void print and it is displaying print derived class, and one is void show and it is displaying show derived class. Now please recall these both two functions with the same signatures, with the same parameters, with the same return type are already being defined inside the base class. The only difference between two functions here is the print function has been declared as the virtual inside the base class, while void show function is declared as a normal function, that is a non-virtual function. What next? Within the main function, as you can see on the screen, we have one pointer which is pointing towards base, and it is having the name base bptr, that is a pointer to the class base, or we can say that is a pointer to the object of the class base, and with that we have one object of derived class also. Now till this point we are very clear with this fundamental that within the pointer of the base class, the address of the object of the derived class can surely be stored, and similar thing has been taken care here that bptr, which is the pointer of the base class, in this we have assigned the address of the derived object. So here we can say both the functions are binded. One function which is print, another function which is show are binded. The only difference is whenever we are talking about virtual function, these virtual functions are binded at runtime, while the non-virtual function which is show is binded at the compile time. So when we say base ptr, which is bptr, using an arrow operator we are calling the function print. So what are we doing? We are calling the function print using the through base ptr using the arrow operator. So base ptr arrow operator print function, and similar kind of implementation we are doing with the function show, which is base ptr arrow operator show. So basically what are we trying to do? We are trying to call the function print as well as the function show using the pointer to the base, but please remember this pointer to the base is having the address of the object of the derived class, and finally we are kind of closing our main function using the standard statement which is return 0. So now one function which is virtual is print, and another function which is non-virtual is show. Now what kind of output we are expecting here? So output here is the print function which is binded at the runtime will say print derived class. That means the derived class version of the print function has been taken because it is declared as virtual, while when we say show base class or whenever show base class is printed, that means which version of the show function is implemented or is executed here is the base class version. So now what is the difference? The difference is the derived class version of the print function, while the base class version of the show function is executed, while the whole implementation is same. That means the print function is also called using bptr through arrow operator, while your show function is also called using bptr, that is the base pointer, with the through the use of arrow operator. This bptr for both the cases, for the case of calling the print function and for the case of calling base function, for both the functions, for both the cases, this bptr is having the address of the object of the class derived, but for one particular function it is printing the derived class version, while for the another function, which is the show function, it is taking the base class version. Why? The difference between print and show is print has been declared as the virtual function inside the base class, while show has not been declared the virtual function. It was just kind of defined or declared as a very normal function. So here we can say runtime polymorphism is achieved only through a pointer, or here it could be a reference, and this we have seen in our previous lectures that we can use this runtime polymorphism either by taking the pointer of the base class or by using the reference to the base class type. So runtime polymorphism is achieved only through a pointer, or we can say a reference of the base class type. Also, a base class pointer can point to the objects of the base class as well as to the objects of the derived class. Both it can point. So, base class pointer is eligible to point to the base objects of the base class. Also, it is eligible to point to the objects of the derived class. Although in this program which we have just seen, we have just used base class pointer pointing towards the objects of the derived class. So in the above code, what we have done, this base class pointer, which is BPTR, contains the address of the object D of the derived class. So it will bind at runtime, that is the output is print derived class as pointer is pointing towards the object of the derived class, and here the print is actually a virtual function, while the show being a non-virtual function, it will be binded during the compile time, and hence it is showing the output it is showing is from the base class version of the show. So just the word virtual or the declaration of two function is different. One is virtual, another one is non-virtual. Same other the things are same. So here we are able to see runtime polymorphism with the help of the pointer pointing towards the object of the derived class. So if we have created a virtual function in the base class, it is being overridden in the derived class, and this particular mechanism we have seen. If it is being overridden in the derived class, then virtual keyword is not required in the derived class, but yes, in the base class it is definitely required, because these functions are automatically considered as virtual function inside the derived class. So inside the derived class we are not going to put any keyword as virtual, but yes, whenever we are creating a virtual function in the base class, we need to precede the declaration of the function with the keyword virtual inside the base class, and it will be overridden in the derived class without the requirement of the keyword virtual there. Now this was basically, we can say how these virtual functions are inherited and how non-virtual functions behave if we treat them in the similar manner. Now coming to the another topic which is very important in case of virtual functions is pure virtual functions. So here we have, till this point we have seen that a function declared as virtual is defined by the base class, and it is kind of redefined, or we can say overridden by the derived class or maybe derived classes. So how many derived classes are there, that depends on the application. So but when a virtual function is not redefined by a derived class, the version defined in the base class will be used, and this we have seen in our previous lectures. Then wherever derived class is not redefining the virtual function, the version which is the version of that particular virtual function which is defined in the base class will be used. Now sometimes this happen, or in kind of many practical real life scenarios, this is a scene which is possible, that the base class is kind of not having any meaningful definition of the virtual function. So, in many situations there can be no meaningful definition of a virtual function within a base class only. I am not talking about the derived classes. Derived classes, yes, definitely they will be providing their own redefinition which is meaningful to them, but there are situations in which at least for the base class there is no meaningful definition of the virtual function, because in any case derived classes are going to have their own versions of that particular virtual function. Another or this situation could be a base class may not be able to define an object sufficiently to allow a base class virtual function to be created. This is also a possible situation. In another scenario, we can observe that for sometimes it is mandatory for the derived classes, or we want this to become mandatory for all the derived classes to override a virtual function. So, there are some situations in which we need to ensure that all derived classes must override the virtual function, and in the similar situation or in another situation could be your main or your base class is unable to provide any meaningful definition to that virtual functions. To handle these two cases, C++ supports another kind of virtual function, or we can say a twist or a tweak in the virtual function, and that twist is known as pure virtual function. Now, let us try to understand that what is this pure virtual function. So, a pure virtual function, as the name indicates, it is going to be a virtual function, but there are two conditions with this virtual function, this pure virtual function, and the first condition is that it has no definition within the base class. So, whenever I am saying there is no definition within the base class, that means now the question arises that how this pure virtual function will be declared. So, in order to declare a pure virtual function, we will using a general form which says virtual, then type here is nothing but the return type, then the name of the function, so and the parameter list equals to 0 followed by a semicolon. So, here is a general form of a pure virtual function which is going to be kept inside the base class. So, to declare a pure virtual function, we will be using a general form which is virtual return type function name within the parenthesis parameter list equals to 0. So, this could be virtual void print and the parameter list if it is required, or blank equals to 0. So, now what happens with this virtual function which is being made as pure? That means we are not going to provide any definition here within the base class at least. So, when a virtual function is made pure, any derived class must provide its own definition. So, here I am repeating it. When a virtual function is made pure, any derived class must provide its own definition. So, now here are the two agendas which we have taken as the base of pure virtual functions were: one is base class is not having any meaningful definition to provide, and we want it to be mandatory for all the derived classes to provide their own definition or to override that virtual function. So, what we have done, we have declared them as pure virtual function. And what is the way to declare a virtual function as a pure virtual function? We will not provide its definition, and instead we will write is equals to 0. So, virtual type function name parameter list equals to 0. So, whenever this type of a general form is encountered, your compiler is ready to take that particular virtual function as a pure virtual function. So, no definition is being kind of looked for or is expected within the base class, but yes, all the derived classes, I repeat, all the derived classes must provide their own definition of this pure virtual function, which was the second concern. So, both the concerns are addressed here: base class not providing any meaningful definition, okay, and by declaring it as a pure virtual function by using equals to 0 general form, we are making it as pure virtual function and we are making it mandatory for all the derived classes to override this or to provide their own definition. Now, what will happen if this is not going to take place? That means, if the derived class fails to override the pure virtual function, a compile time error is going to result. That means, if derived class is not having the pure virtual function, a compile time error will result. Then how are we going to use this in the practical real life scenarios? Let us try to see. We have a program with a simple example of a pure virtual function. We have a base class which is class is named as number, which contains an integer called val and the function setVal with a pure virtual function show. So, we have one data member which is val, another function which is setVal, and we have a pure virtual function show. So, for all the derived classes of this base class number, it is mandatory to override, it is mandatory to provide their own definition of show. And we have some derived classes. So, we have 3 derived classes which are hex type, which are named as hex type, dec type and oct type. They all inherit this base class number and they redefine the function show because it is a pure virtual function. So, it is a compulsion for them, and so that it outputs the value of val in each respective number base, that is hexadecimal, decimal or octal. So, that is what the agenda is. We will be taking one value, we will be setting that value using the function setVal, and by making the function show as the pure virtual function, we have we can say we have ordered all the derived classes hex type, dec type and oct type to redefine show in order to output the value of val for hexadecimal in the hexadecimal base, in the decimal base as well as in the octal base. Let us try to see the program. So, here we have one class number in which instead of public we have seen one protected data member int val, and inside the public section we have a setVal which is having an integer I as the parameter, and value of that parameter has been given to the variable val. And by using virtual void show equals to 0, we have made it show as a pure virtual function. Now, after this we are going to define the 3 derived classes of this particular base class number. So, one is class hex type which is inheriting this class number in public, and now it is also redefining show in which it is showing the hexadecimal value of that val. Then we have dec type which is also inheriting the class number in the public mode, also redefining show and having the value in the normal decimal function. Then we have class oct type, again inheriting the number base class in public, and we have void show giving its own definition here as well. Within the main function, we have declared objects of dec type, hex type and oct type, and we have seen d dot set well as 20, then d dot show which is going to display 20, then h dot set well is 20 and h dot show is also displaying 14. So, that is what the here for all the, if you can see the class definitions here for all the three derived classes dec type, oct type and hex type, it is mandatory to provide the definition of show. Although we have seen only usage of only two definitions of show, that is of from dec type and from hex type with the two objects only. So, that is the agenda of the usage of the pure virtual functions. So, in this lectures we have seen how this virtual functions are actually inherited, how non-virtual functions are behaving inside the derived classes in the similar situations, and what is the meaning of pure virtual functions and why do we use pure virtual functions. So, hope you have enjoyed the lecture. Here is a list of references which is being used for preparation of the lecture. Thank you for a patient hearing.